Question 7. Benzene react with chlorine gas to form chlorobenzene. This reaction can be described as a reaction between benzene molecules with this chlorine ion. And the chlorine ion are formed by adding a suitable catalyst. Give the name or the formula of this catalyst, very easy. So it's aluminum chloride. So chlorine with this aluminum chloride, if you get the chloride from this chlorine, and it will form AlCl4 negative, and it will form this chlorine cation. For part B, the mechanism for this reaction is shown. Now you no need to draw the mechanism. You need to, based on this mechanism, answer the following question. For part 1, the movement of a pair of electrons is represented in X, okay, this part. So we can see now the electrons is form the benzene ring. And now it's asking where is the pair of electrons before step 1? Before this step 1 means where is this electrons formed? So it's actually the pi electron system in the benzene ring. So it's always delocalized. The 6 pi electrons in the benzene ring always delocalized like this. So what you need to say is just pi system or pi electron system in the benzene ring. Then state where is the pair of electrons after step 1. After step 1, step 1, then this pair of electrons is moved out and donates to the chlorine ion, and it forms a new bonding. So it's formed a new CCl bond here. So the pair of electrons is used in this one. So you just need to put CCl bond. Okay, part 2. The movement of another pair of electrons is represented by Y in diagram 2 here. So it's the intermediate. So now it's a CH bond break, you see? CH bond break, and these electrons will move to the benzene ring. Restore the aromaticity, means restore the benzene ring. So before the step 2, means this is step 2. Before that, I see the arrow. So the pair of electrons is in this Y, is in the CH bond, you see. So you just put CH bond. Okay, after step 2, where is it? The CH bond will break. Now these 2 electrons will move back to the benzene ring, restore the benzene ring. So means now the electrons pair here will be in the benzene ring. In the benzene ring, where is it? Pi electron system in the benzene ring. Okay, part C. There are 6 carbon in the diagram 2. Actually, this one, this one. So I bring this one and I try to put all the hybridization, the carbon with hybridization here. Okay, so this one is the similar to diagram 2. Okay, but I put the double bond here and the charge positive. This is one of the resonance structure of the species. Okay, state how many of these carbons there are sp, sp2, and sp3 hybridized. So we just look at this one, the carbon with 4 bonding, 4 single bond. So this carbon must be sp3. So all this hybridization, how it's formed, you should roughly know. When we see a CC double bond, means the carbon in the CC double bond, they must be sp2. So means this will be sp2 carbon, this will be sp2 carbon. And this one also must be sp2 carbon, this one must be sp2 carbon. Another part that is quite challenging here, you see, initially, before it's formed this intermediate, actually there are 3 bonding there. So 3 pi bonds there. So one of the pi bonds is used to form this CCl bond, right? So it's gone. Means this carbon, initially there is a pi bond there. When the pi bond's gone, means this carbon lack of a pair of electrons. So means now this carbon with, actually it's not 2 bonding, This carbon actually there is another hydrogen. So this carbon it has 1, 2, 3 bonding, you know. So 3 bonding pair is actually a sp2 carbon. sp2 carbon. So means the sp2 carbon, they are 1, 2, 3, 4, 5. 5. sp3 carbon is 1. sp don't have. So it's 0, 5, 1. That's why we got this answer. Okay, part B. Complete the equation for the reactions between the benzene and chlorine. This is very easy. So chlorine with benzene ring. So one chlorine will substitute the hydrogen, and the hydrogens that get substituted will combine with the remaining chlorine to form HCl. Right. So this is equation. Part E. The mechanism for the reaction is electrophilic substitution. Complete the following sentence. Write the formula in the gaps provided. Okay, during this reaction, the electrophile is the chlorine cation. Electrophile. So from this mechanism, you should know. So this is electrophile, and the benzene is the one that donates the pair of electrons. This is a nucleophile. Okay, so let's get back to that. And a hydrogen atom in the benzene ring is get substituted. So when there is electrophilic substitution, always the hydrogens that in the benzene ring will get substituted by what? By the chlorine atom. So means this one, the chlorine atom. Part F. Chloroethane reacts with sodium hydroxide. Chlorobenzene does not. So of course you need to know how the chloroethane and the chlorobenzene looks like. So this is just a normal halogenal alkane which you learn in AS. Chlorobenzene, and this chloroethane, there is a difference. This chloroethane can react with sodium hydroxide. Very difficult for this chlorobenzene. Later you need to explain why. Okay, so first, name the mechanism of the reactions that chloroethane undergoes with the sodium hydroxide aqueous. This is in AS. AS. And identify the major organic products. Okay, so recall what you learned in AS. This one is a primary halogenal alkane. So the hydroxide will donate a pair of electrons to this partial positive carbon to form a new bond, and it will form this intermediate. So the CCl bond will break and it will form chloride, and it will form the ethanol, the alcohol. So the major products from this nucleophilic substitution is ethanol. So this we call nucleophilic substitution. Why? Hydroxide is a nucleophile. It substitutes the chlorine. So we call nucleophilic substitution. Major product is ethanol, as I told you just now. Now in this part you need to explain why the chlorobenzene is not really that reactive. It cannot react with the sodium hydroxide in the water, in aqueous solution. So first, let's look at this diagram. So chlorobenzene, you see, the chlorine, if you use, or if you let its lone pair, one of its lone pair, to delocalize into the benzene ring, you see. When the delocalization is happen, you can see that some of the resonance structure is formed double bond. A double bond is actually stronger, right? Therefore, it's harder to break. When it's harder to break means it's harder to react, you see. So that's the reason why the chlorobenzene is hard to react with this sodium hydroxide in aqueous solution. So it means it's hard to undergo hydrolysis or the substitution. So that's why you have this answer. The lone pair on chlorine is delocalized in the pi electron system in benzene ring, like this, this movement. No need to draw this mechanism, which making it partly double bond characteristic. So it has this partial double bond characteristic, which is a stronger bonding, stronger than this single bond, which is stronger. That's how you explain for this chlorobenzene. Okay, that's all. Thank you.